welcome to this video. In this video, we're going to solve this problem here. So we have a rectangle and then we have a half circle inscribed in this rectangle, and then we have a straight line crossing this circle at this point P. So this problem is from Presh Talwalkar's channel, Mind Your Decisions. And in his solution, he used some basic trigonometry to solve this problem. And I was thinking of showing another way of solving this problem by using calculus. A small hint, the solution is actually much harder to find by using calculus, but I thought of showing it anyway. So I have this problem. So we're gonna find the area here. So the red area here, and this line here, which I call f of x, the function f of x. And then we have this half circle, which I call the function g. And these two functions intersect each other at point P. So I start by expressing the straight line. So we know that a straight line f of x equals to, we can find the slope of this line by taking this point here, and we know that the straight line crosses the origin of this coordinate system. So we have created this coordinate system where we have the origin here. So we have this point here. This point here is this point here has the coordinate 2r, comma, so 2r, comma, r. And we know that in order to find the slope of this line, we can take this y value divided by this value here. So we will get r divided by 2r, and we have x here. So the slope is actually 1/2. So f of x equals 1/2 x. And then we have to find the formula for this half circle here. So this circle has a radius r, and it is centered at r comma r. We have r comma r here. And then we can express this circle using this formula here. So x minus r squared plus y minus r squared equals r squared. So this is the formula for a circle centered at r comma r. So this is the center point's x value, and this is the y value of the center point. And we need to express a function, so we have to solve for y. So having this equation here, we have to solve y here. So first I move this term to the other side. We get this expression here, so minus x minus r, x minus r squared. So we have y minus r equals the square root of this expression here, because we have to cancel out this square root. No, we have to cancel out this exponent of 2. So y minus r equals plus minus square root of r squared minus x minus r squared. And then we just move minus r to the other side, and then we get this expression here. And we can see that we have two solutions. We have this solution here and the other one with a negative root. So plus and minus here. It's actually this solution which is interesting. So this one is the one we are looking for, because this is the lower part of the circle. So the lower half part of the circle. So if we look at GeoGebra, we can see that this one is actually the negative root of the solution. The positive root is the blue part of the circle. We're interested in the lower part because we have the intersection point P there. So this is the interesting interesting formula. So we call this G. So G of x equals r minus square root r squared minus x minus r squared. Okay. So the next step is actually to find this intersection point because we want to use integrals to find the area. So what we want to do is to find this intersection point. So this intersection point consists of an x and y value. And then we can integrate from here to this x value and find the area under this line here, under this line f of x. I have drawn a figure down here. So we're interested in integrating, computing the integral from here to compute this area here. And then we have to compute the integral from this x value to this x value here. Then we will get this area here. Okay. So let's continue. So this intersection point P then. So this point P here, the blue point, we have to set f equals g. Okay, so both functions have to be equal each other. And then we have 1/2 x equals r minus square root r squared minus x minus r squared. And solve for x. And then we see that what I did here is that I moved this term to the left hand side and I moved this term to the right hand side. We get this. And the next step is actually to take the power of 2 here and this side. So we have to square both sides. So if we're squaring, the square root left is only what's inside the square root. So we have this one here. And then we have to square this whole expression here on the right hand side. And then doing some algebra. So these cancel out each other. So we have r squared minus, and then this expression here is x squared, and then we have this minus there. And then we take this times this, and then double it. So it becomes 2xr, not minus, but then we have this minus, it becomes plus here. And then we have minus r squared equals r squared minus rx plus 1/4 of x squared. And we just continue doing the algebra and we end up with this expression here. Okay, so x squared minus 12/5 rx plus 4/5 r squared. So this is the constant part of the equation. We have x squared here, and then we have this part here, which is the coefficient of x. So we can now solve x and find out the value of x, or the expression of x. So there's a formula to solve a quadratic equation. So we just half this 12, we get 6/5, and just change the sign here. So it becomes 6/5 r, and then plus minus square root, and then you just square this coefficient here. Actually, you square this one. It becomes 36/25. And then r squared minus, and then you take minus this constant term here. So minus 4 over 5 r squared. And then just continue on, you can see that this is simplified to 16 over 25 r squared. And if we take the square root of this, it becomes 4 over 5 r. And now we have a expression for x value. So we have the x value is 2r. And then we can find another x value, which is 6 over 5r minus 4 over 5r, which is 2 over 5r. And then the corresponding y values. We are actually not interested in those, but it can be good to know. So I've computed them anyway. So we have r here, and then the 2r comma r is one intersection point, and then we have another one which gives us 2 over 5r, and then I've computed it by using the formula or the function for this half circle. I could have used f of x. I realize now it's actually much easier. So we get this point P, which we are actually interested in. So 2 over 5r comma 1/5 of r. So we can see that this point 2r comma r is actually the point up there. It's the point up there. Okay. But we're interested in this point P then. So P is this one. Okay, P is this one. So now we have to express the area of this red region here. The area by using, so we are using calculus. This becomes quite complicated now, but it's still possible to use calculus to solve this problem, but it's not the easiest way. So the area, the red area A equals, we have to compute the integral from 0 to this x value of the intersection point here. So from 0 to 2 over 5r. And then the function is this one here, f of x, so 1/2 x dx. And then we have to add the other area, which is this one here. So we have to integrate, so the integral from 2 over 5r, so from here to r, okay, so 2 over 5r to r, but then we have to use the formula for the half circle. So the formula for the half circle, so r minus square root r squared minus x minus r squared dx. So this is the g of x function, the g function. And then we see that the integral here is quite trivial. So the antiderivative of this one, the primitive function, is actually x squared divided by 4. And then you have the interval from 0 to 2 over 5r. But what I did next is that I decomposed this integral into two integrals. So we have here the integral 2 over 5r to r, the same interval, but we have r here instead. Okay, r dx minus, and then the other term of the integral. And this integral is also trivial to find. So we have, so this is the one we computed here. And then we have r times actually just x, because the derivative of x is 1 and left is only r. And then the same interval. And then minus, which is this minus here. And then we have this integral here, and we have to focus on this integral, which is quite complicated to solve this one. If you look at it, we have the integral 2 over 5r to r, and then square root r squared minus x minus r squared dx. Okay, So in order to solve this integral, we have to use a substitution method, because this function here consists of a function which is the square root, and inside we have another function, so it's a composition of functions. And one way to solve this integral is actually to use the substitution method. So we have to set, in this case, we have to set x minus r equals to r times the sine of theta, so the sine of this angle. And the reason we do this is that we can re-express this into a simpler expression here, and hopefully we will find the primitive function of the more simplified function after we do this substitution. So we have x minus r equals r times sine of an angle. So we have sine theta equals x minus r divided by r. And then we can solve for theta now. Okay, so theta equals the inverse sine, so arc sine of x minus r divided by r. But we can also solve for x. So up there we solve for x, so x equals r times sine theta plus r. And then what we can do next is we can compute the derivative of x with respect to this angle here, theta. So dx d theta equals r cos of theta. So this is a constant, it becomes 0, and then the derivative of sine becomes cosine. Okay, so I have the derivative of x with respect to theta is r times cosine of this theta. And then we can solve for the x, so we can get the expression for dx. So dx equals r cosine of theta times d theta. So this expression we're gonna use and replace the x here actually with r cosine theta of d theta. Okay. So what we get now is we have here integral. I will explain the intervals here, the lower x value and upper x value. So we have square root r squared minus, so x minus r is actually r times sine theta. So we have x minus r is this thing here. Yeah. So this becomes r squared times sine squared theta. And then we have dx, and dx is the same as this thing here, r times cos theta times d theta. So r times cos theta times d theta. So we have this integral here, and we can see that for this lower x value, so 2 over 5r, and for x equals r, so we can see here for x equals r, if we use this expression here to find a theta value, because we are now integrating in this axis now, which we call theta. We have to express the lower and upper the lower and upper values in terms of theta. So theta is arc sine of x minus r divided by r. So x equals r now. So we have this theta equals arc sine, and we have r minus r divided by r. So this becomes 0, because this is 0. And then for x equals 2 over 5r, we get this value for theta, which is the same as arc sine. And then we have 2 over 5 r minus r divided by r. So we get minus 3 over 5 here. Right, so theta, the lower part of the integral here becomes sine, arc sine minus 3 over 5. So we have this expression. So here, so the integral, let's look at this integral. So integral arc sine minus 3 over 5 to 0. And then we have this new expression here. And we can see that by doing this substitution, we see that we get this integral now. So we can factor out here, factor out r squared. And we get square root r squared times 1 minus squared sine, okay? And 1 minus the squared of sine becomes the square of cosine, okay, the square of cosine theta. So you just square cosine. And then we have r times cos theta d theta. And we can see that we can take the square root of r squared, which becomes r. And then we have square root of the square of cos theta. And this thing becomes just cosine of theta. And then we have cosine of theta here times cos theta. And it becomes the squared of cos theta. And then we have r squared because we have r here, and we have r here. So the next step, so we just keep going. So we can factor out r squared here, the integral, and this lower and upper limit. So lower value and upper value. And then we have cos squared theta d theta. And then we can see that the cos squared theta equals this expression here. So the reason that we are rewriting this is that we can more easily find the primitive function. So it's quite hard to find a primitive function of cos squared theta because it's a composition of two functions. So we have both the squared, okay, the exponent 2 and the cosine function. But we can rewrite it in this way without the squared thing here. So it becomes this cos of the double of this angle theta plus 1 divided by 2. So we rewrite it like this. And then we can factor out 1/2. 1/2 is here. And then we have the integral and these values here. And then cosine the double angle plus 1 d theta. And this one is easier to find a primitive function too. So the primitive function is now, we have sine 2 theta divided by 2. So if we find the derivative of this thing here, we get cosine, and then we have the 2 which comes outside here, the 2 here, and then we have theta. So 2 theta, but cos here, and then a 2 here, and then this 2 here cancel out with this 2 here. So it becomes this thing here then, okay? And then the derivative of theta becomes 1, okay? So we can compute this integral now. So we can see that the integral here, we have 1 over 2 r squared, which is this one. But if you insert 0 here, this becomes 0, and this becomes 0. So I have this 0 here. And then we have minus, and then we have this big parenthesis, which is this thing here. Okay, so now we have to insert this lower value here, lower theta value, and then we have 1/2 times, so 1/2 is this thing here, 1/2 here, times the sine of 2 times the arc sine of minus 3/5. Okay, and then plus the arc sine of minus 3/5. Okay, so this thing here looks quite complicated. So this thing here, this one, so the sine of 2 times the arc sine of something. So this expression is actually quite complicated, but it can be simplified by looking at this part here. We can say that we have the expression y equals sine, the arc sine of x. Then we know that x equals the sine of y. And then we have a formula for sine of a double angle, which is the same as 2 sine y times cosine y. And then we use this trigonometry identity. So squared cosine y plus squared sine y equals 1. And then we see that the squared cosine of y equals 1 minus x squared. Okay. And then we can see that the cosine of y then equals to the square root of 1 minus x squared. And then we can see that the sine of 2 times the arc sine of something. Okay, so the arc sine of something we have here, which is y equals the sine minus 1 of x, okay, which is this y here. Okay, but we can see that it becomes 2x times the square root of 1 minus x squared. So this 2 is this 2, and sine y here, sine y is actually x. Okay, and then we have the cosine of y, which is square root of 1 minus x squared. So the whole thing becomes 2x square root 1 minus x squared. Okay, so we have this expression here. So we have 1/2, which is this thing here, and then the 2 here is the 2 here, and x is whatever with whatever is inside here, inside the arc sine here, which is minus 3/5. And then we have this square root 1 minus, and then we have to square whatever is inside this arc sine here, which is x. So minus 3/5 squared. And then we have minus here because we have this minus sign here. So this becomes minus here, but this plus becomes minus here. Okay. And then we just simplify the expression here. So we have this cancels out this thing here, right? And then what's left is 3/5 because we have the minus here and minus here, becomes plus. And then we have the square root 1 minus this thing here is 9/25. And then we have the minus arc sine of minus 3/5. And then this equals to, and we simplify this. This thing here is the square root of 16/25. And then we keep simplifying, and then we get 3/5 times 4/5. minus and then the arcsine thing. And then this is the same as 12 over 25 minus arcsine minus 3 over 5. And then this equals to 12 over 25 here. And then we have the 1 over 2 r squared minus sine arcsine minus 3 over 5 here. Okay, so this is the computed value of this integral here. So this value is the computed value of this integral, okay, without the minus sign, okay, without the minus sign. So this integral we have computed now to this thing here. And then now we can compute the area. The area is the same as we have this integral of the first term and then the second term and then the third term, which is the one here we computed recently. So this integral becomes, we take this 2 over 5r and square it, and then we divide by 4, we get 1 over 25 r squared. And then we have r times, we insert this one here, and then we get r minus, and then we have 2 over 5r, this thing here. And then we have minus, and then we multiply this in here, minus 6 over 25 r squared plus, and then we have this 1 over 2 r squared arcsine minus 3 over 5. This equals to, and then we just simplify everything. So we see here it becomes, this is 5 over 5r minus 2 over 5r, so 3 over 5r squared. And then we have this term here, and this term is this term here, and this is this. And if we simplify, we get minus 5 over 25 r squared plus 3 over 5 r squared plus 1/2 r squared arcsine minus 3 over 5. Okay. And we can see that this fraction can be simplified to this, and then we evaluate this expression, and then we get 2 over 5 r squared plus 1 over 2 r squared arcsine of minus 3 over 5. And this minus here we can actually move out here then, because we have this formula here that the sine of a minus angle equals minus sine of this angle without the minus sign. Okay. So what we get is the same expression, but we just change the plus to a minus and then remove the minus sign here. Okay. And we can rewrite it without fractions, so, and then we can also factor out r squared. So we have r squared here times 2 over 5 is 0.4 minus 1 over 2 is 0.5, and then we have the arcsine of 3 over 5, which is the same as this is the same as 0.6. Okay, but we can rewrite it as the video in Mind Your Decisions. So we have 0.5 minus 0.4 minus 0.5 arctan. Okay, so we know that the arcsine of a triangle here is the same as 3 over 5. So this is the hypotenuse, and this is one side. So we have 3 over 5, and by using the Pythagorean theorem, we can see that this side have to be 4. So 3, 5, and 4 here then. So this is 4, so we can rewrite it to arctan. Arctan is then 3 divided by 4. Okay, so 3 divided by 4, so 3 over 4 is the same as 0.75. So the area becomes r squared times, okay, 0.4 minus 0.5 times arctan of 0.75. So I have shown a way to actually solve this problem by using calculus. And you can see this is a way more complicated way to actually find a solution. So the way that Mind Your Decision video presents the solution is actually the easier way to solve it. And the calculus way is quite complicated, but it's possible, which I've shown here in this video. So I hope you enjoy this video. If you like it, please like and subscribe, and see you in the next video. Bye bye.